Okay, welcome back. So we're going to try and see what happens if we don't have a special or if we don't have an exact equation. Okay, so we're assuming we're taking p dx plus q dy equals 0 and partial of p with respect to y is not equal to the partial of q with respect to x. So the equation is not exact. Okay. So what are we going to do? We're going to see, can we find what we call a special integrating factors? Similar idea to what we did earlier with integrating factors, but a different integrating factor. So a special integrating factor. Okay, mu of xy, so that's what the ST stands for, mu of xy p dx plus mu xy q dy equals 0, and the partial with respect to y of now mu of xy times p, which let me write the dependence there, equals the partial with respect to x of mu of xy q of xy. Okay. Okay, so let's go ahead and expand this out. So taking the derivative on both sides, let me do this in blue. So partial of mu, oh, don't like how that looked. Partial of mu with respect to y times p plus mu partial of p with respect to y should equal partial of mu with respect to x times q plus mu partial of q with respect to x. Okay, we're going to go ahead and we're going to put the derivatives on one side and the mu's on the other. So mu partial of p with respect to y minus partial of q with respect to x should equal, on the other side, we're going to have partial of mu with respect to x, q minus partial of mu with respect to y, p. Okay, so here's our problem, okay? This equation is often harder than the original. That's no good for us, okay? But there are situations where we can do a simplification. So this is simplified if mu is just a function of x or mu is just a function of y. Okay, if mu is just a function of x, then what's going to happen? This is going to be 0, right? And we have the equation partial mu with respect to x equals mu partial p with respect to y minus partial q with respect to x divided by q. We could solve that. If mu is, sorry about that, I'm getting carried away with my lassoing. In this situation, if mu is a function of y, okay, then this is going to be 0, right? So if this is 0, okay, I can again solve it. I'm going to write partial mu with respect to y equals mu, sorry, let me put the negative sign here. Mu times partial p respect to y minus partial q respect to x divided by p. Okay, so all right. I will admit something to you that I don't like to admit, but even I, who use math more than most people, I've never actually used this outside of a differential equations class, but I just think it's fun. So that's why I'm teaching it to you, and it's also part of the course. I'm sure that maybe some of you will see this in other contexts. I have not yet ever seen it, but the other stuff with the exact equations, I have seen that. And I'm sure I can imagine many places where this might be a factor. So never know what you're going to need, but I'll be honest, I have not used this yet, I should say. All right? All right, we'll be back with some examples.